Consider this electric circuit. 3 resistors, 15 ohms, 25 ohms, and 35 ohms, are connected in series in a circuit. What is the equivalent resistance of this combination of resistors? And what is the total current from the 12-volt battery? First thing we need to do is draw a simple series circuit. It says here that this is a series circuit, and we're going to be using a 12-volt battery. The symbols for these items, here's a battery, and we're going to draw some wires, leads that come out of the battery to make the connections. This is the symbol for a battery. The long bar is the positive, and the short bar is the negative side of a battery. The way I best remember this, which one is positive and which one is negative, is if I take this positive sign and stretch it out. Here's the horizontal bar, and if I take the long bar, the vertical bar, and then put it next to it, it becomes the long bar. And of course, then we have the negative for the negative here. And we have 3 resistors, and the symbol for resistors is this zigzag shape. There's 1 resistor. Here's 2 resistors, and 3. And that's all there is in this circuit. There's a battery, 3 resistors, and we need to close the loop. And these lines right here, this represents wire. And we have here a closed loop. By convention, the current leaves the positive side of the battery, or a charge will leave the positive side of the battery and go around the circuit in this fashion, by convention. Each one of these resistors has a value, and doesn't matter which one of these we use, we'll just start and put them in order. So the resistance here is 15 ohms. And this one is 25 ohms and 35 ohms. This symbol here, that is a symbol for resistance. It is the Greek letter omega, and it is the unit itself is named after George Ohms. George Ohm, without the E. And this is pronounced 35 ohm. 25 ohm, sometimes pluralize it, 25 ohms, and 15 ohms. And again, the symbol or the unit is represented by the omega letter of the Greek alphabet. And each one of these represents something. For instance, we'll make this a light. And this one here, we can make this represented as, let's see here, a computer that's being connected up in your room. Something that's using electricity. Then we have a light or light bulb and a computer. And something else here. Let's say you have your cell phone on charge. It's using electricity. There's nothing representative of these resistances here. I'll just throwing those in. But anyways, here's our circuit. And the question says, what is the equivalent resistance of this combination of resistors? What it's asking us to do is to take these 3 resistors right here and change them into 1 resistor. That will be an equivalent resistance. And often this is a series circuit, looks like this. Sometimes you can rearrange this such that it looks like this. And it's still a series circuit. I'm going to take each one of these resistors. I'm going to slide them over. Take this one, slide it over here. Take that one and slide it over here. Such that the circuit looks like this. They look different, but it's the same circuit. How do I know this is a series circuit? Series. It's when I draw the circuit. If my pen does not leave the paper, starting here, I trace this, my pen does not leave the paper at any time, going all the way across and back to the battery, that is a series circuit. And I can call this here resistor number 1, resistance 1. It has a value of 15 ohms. And we'll call this one resistance number 2. And we'll call this resistor number 3. And to find the equivalent resistance of these three, we look at our equations. For a series circuit, the equivalent resistance, Req, is the summation of all of the resistors. And I use the word resistor and resistance interchangeably because they simply just use up electricity. So the equivalent resistance is the summation of all of the resistors that are in series with each other. Therefore, the resistance equivalent, R equivalent, is equal to R1 plus R2 plus R3. And we have the values. It's a matter of plugging in the values. And all of them are in ohms. Plus 25 plus 35, add them up, and it's 75, and the unit will still be ohms. This equivalent circuit, then, I can rewrite this circuit, or redraw this circuit, I should say, like this, using the equivalent resistance. Here's the battery. And here is one resistance, or one resistor, representing all three of these, representing all three of them, and it has a value of 75 ohms. And current leaves the battery by convention. A charge, or in our case the current, will leave the battery from the positive terminal and go around the circuit and back into the negative. This will be current. And I should put letter I represents the current. And this battery has a voltage. It's written right here, 12 volts. A 12-volt battery. And the question says, what is the equivalent resistance of this combination of resistors? Well, the equivalent resistance is 75 ohms. That's already been found. And part 2 says, what is the total current from a 12-volt battery? So we can calculate the current here, but we can't calculate the current here with only one resistance. By using Ohm's law, we're going to find the current. Find the current I. Ohm's law states voltage is equal to current times the resistance. We want to find I. So I'll just rearrange this equation, divide both sides by R, and it looks like this. Voltage divided by resistance is equal to the current. All we have to do now is put in the units, or the values for each. Therefore, the total current that is being drawn here from the battery as a consequence of using a light bulb in a computer and a cell phone charger all at the same time, it's going to draw some current from your source all the way around. And current total then is equal to the voltage of the power source, the EMF, 12 volts, divided by the resistance. This is the equivalent resistance, R equivalent, which is 75 ohms. Putting this here in the calculator then, current total is equal to 12 divided by 75 is 0.16. And when you divide voltage divided by resistance in ohms, this is volts. And here we have ohms. We have another unit called amperage. And this is shortened to amps. Current total is equal to 0.16 amps, or 0.16, and the letter A is used to represent current amps.